You should only be watching this video if you have completed slide 3, so make sure that all of your answers are put into one of those categories before you start this video. So in this video, we're going to do a reflection over that activity, and I'm going to tell you how to complete slide 5 in your slide setup. So this should be what your completed slide number 3 looks like. So this is just a sample of it. You should have put any whole numbers, so any counting numbers that are positive in the whole numbers, any counting numbers that are negative into the integers, and then we've got a lot of fractions and decimals into the rational number category. So I want you to take a good look, see if you have any questions about the placement of these numbers that I have here. One question I had a lot was for numbers like this. We've got 10 over 2. 10 over 2 is a fraction. It's not necessarily a whole number what we're looking at right now. And so a lot of times people throw this into the rational number category. But 10 over 2 simplifies to 5 because 10 divided by 2 is 5. And so while you're solving this problem here, you're actually thinking about where 5 sits, not where 10 divided by 2 sits. So make sure that you simplify your fractions to the lowest possible term. So like this one, for example, as well, I know that 12 divided by 3 gives me a 4. And it does have a negative, so it's going to be a -4, which is why it got thrown into that integers category. Hopefully you're able to make a definition for rational numbers, and that's what you're going to be doing later on. However, I would like to discuss one more thing before we move on. So if you notice, and you can especially tell in this slide here, each of these are within each other. Think for a minute about why I might have formatted it like this. Why is the whole numbers inside the integers, which is inside the rational numbers? So when you're looking at this, if I classify 4 as a whole number, because it is a whole number, that 4 is technically a whole number, but it's technically an integer, and it's technically a rational number too. So the way that I described it is it's kind of like slices of cake. That whole number is going to be your top slice. And so if I get a section from this whole number here, so if I cut into the cake right here and I get that 4, I'm getting all 3 layers of cake. If I'm looking at this number and I take this slice of cake over here, the only slice that I'm getting is going to be that bottom layer, that rational number. And so if I'm asking you to classify numbers, if you see 4, for example, you would call 4 a whole number and an integer and a rational number. If I had -8 in here, think about that layer of cake. What are you cutting into? Well, you're cutting into integers and rational numbers. So this -8 is an integer and a rational number. Now what I want you to do is to make your own definition. So that was the whole goal of this assignment, is so you can start thinking about what a rational number is and how to classify one. So I started off some sentences for you. So you're going to say a rational number is, and you can say anything you want. I would suggest that you look back at slide 3 and see what kinds of rational numbers that you have up here and kind of group them up. What makes these rational numbers different from integers and from whole numbers? And then I know this because, so you're looking back here and you're looking for examples. So give me some examples for this I know it, this because section. If you have any questions at all, please send me an email.